Okay, we didn't do our 10-minute math yesterday. Hey, we didn't do our 10-minute math yesterday because we didn't have time with the artist. So here's what's going to happen. I'm going to read you a number, and you're going to write it. Then we're going to check to see if you got it. So for example, the first one is 96,467. 96,467. Mental math fluency. They're right here, they're under here, so I'm reading you a number, you're writing the number down, and then when we're done, like I said, 96,467, then we'll check them, like this. 96,467. So that's what we're doing. Oh, I'm not sharing the screen. That's probably part of the problem. Here we go. The second number, 83,050. 83,050. 83,050. Does anybody need to hear it again? Okay, here we go. Here's what you should have written down. 83,000 before your comma. 50. No hundreds. No ones. Last one for this group. 12,006. 12,006. $12,006. Okay, what should the number look like underneath there? Parker, what comes first?
1, 12, 2, 0, 0, 6.
Very good, Parker. Next one. You guys are doing a good job. Yeah, right, Chase. You're doing a good job, Chase. All right. Next one's bigger. 403,591. 403,591. One last time. 403,591. Just like how Parker did it. Danielle, you're up.
403,591.
Excellent job, Danielle. Next one. 840,302. 840,302. 840,302. Falcone.
840,302.
Very good, Falcone. Kaka. Thank you. Next one. 600,070. 600,070. 600,070. Roger. 070. Thanks. Okay. Now the toughest ones.
Million.
Millions, yeah, millions. First one. 7,834,567. 7,834,567. Macy.
7 8 3 4 5 6 7.
3, 4, 5, 6, 7?
Yep.
Yeah, okay. That's something I noticed.
I noticed that it starts with 7, 8, and then it goes 3, 4, and then 5, 6.
Oh, it does.
Yes, you're right, it does. Okay, next one. 2,348,000. Thank you for the applause. I know I'm doing awesome.
Say
2,348,000. I'm so confused by what's going on.
You tried to grab my pencil.
And everything went.
Kaboom.
Okay. All right, 2,348,000. Radley.
2 0 0 0.
Because there were no thousands, right?
Yeah.
Very
2
good.
0 0 0 3 4 8.
Very good. Last one.
The hardest one of them.
98,501,003. 98,501,003. B money.
98501,003.
Very good. You guys did a really awesome job with that. Being able to understand that each set, 98 million. Then just listen for the number. 501,003. Understanding that it's just breaking it down into the sets is huge there. Okay, so just to get us going in, I'm going to get us to the page that we're supposed to be on here. But I'm going to get us started with a problem, kind of an extra problem. We were working on fractions yesterday. And while working with fractions, we learned that there are many different ways to break these up. And that even when we do it kind of the same way, you can get different answers. So I just want to do a quick one in your notebook to get us going before we do work on page 69. So in your notebook, we're looking at this problem. There are 5 kittens. Okay, 5 kittens, and they are sharing 6 cups of milk equally. So what are we splitting up, the kittens or the milk?
No.
Milk. 5 kittens, 6 cups of milk. So I would draw, if it were me, I would draw the milk. Now to represent the cups, I'm going to make circles. How many do I need? 6. You should do the same. You should try and make them approximately the same, but obviously, you know, if you're freehanding it, that's not the easiest thing to do. So now the thing that you need to learn about how to do these, you need to learn how to split things into, how to make fifths, how to make sixths. So when I'm doing it, that's probably the most important thing to take away. I know I showed you how to make thirds yesterday. Today I'm going to show you how to make fifths.
I had a question for like the thirds. Can you do just a Y, or do you have to do an upside down Y?
You could do a Y.
Well, it can be anyone.
That's just how I make mine. A Y would work the same way. But the reason why I go from the top down is because then I think about, if I'm making a Y this way, I have to think about making it a really, when I make a Y, you see how it's, this would be smaller than these two?
Mm-hmm.
So why I go the way that I do it when I'm making thirds is because then I think about, okay, I've got to make a really wide Y. You see? That's why I go that way. Now, you maybe have a different way, that's fine. I'm just explaining to you why I do it the way I do it. Okay, so fifths, because there are 5 kittens, right? We're going to do this 2 different ways. One thing that I told you to always, always, always consider is, can each kitten get 1 cup of milk?
Well, how many kittens are there?
How many kittens are there?
5.
5. So we have 5 kittens. Can they each get 1 cup of milk?
Mm-hmm.
So one way to split this up would be to go like this. Kitten 1 gets this, kitten 2, kitten 3, kitten 4, kitten 5, right? What do we got to do with that last one?
Put it into fifths.
Here's how you do fifths. Okay, everybody watch me. Pretend that there's a circle going around me, okay? Now imagine that my head goes, I have really tall hair. There's your fifths.
That doesn't work.
1 line, so 1, 2 sections, 3 between my arm and my head, 4, 5. So that's how I think about it. Is I think about it like if I were to draw a line down to the middle, and then this is the body. Arms, legs. Now, are they perfect? It also kind of looks like a star. Yeah, Hadley.
Another way you could do it is just do make a 3 and then add, or make.
But if you do that, you're not going to get it perfect. Okay, she's saying you can make thirds.
Whoa.
It's not as accurate.
Make these a little small.
Yeah, it's not as accurate. So what I tell people to do is start from the top, go down to the middle. Then pretend it's got arms reaching out this way and legs reaching out that way. And you're not going to probably make it perfect. But the main thing is that we have 1, 2, 3, 4, 5, and we're going to pretend they're equal, right? Cat 1 gets this. Cat 2 gets 3, 4, 5. So our answer for this, how much milk would each kitten get? Write it down in your notebook. Okay, Mike, maybe leave the flag. I'll come kill it so that you don't have to clap anymore. You missed it.
It's a sneaky one.
He is a sneaky one.
It was on your head.
Just relax, don't and then he will drop.
No, he's right there.
Yeah, he just dropped. We'll just let him go. We'll get him later. We're good. Okay, how much milk does each cat get, Maddie? 1 1/5. They get 1 whole cup. And down here, we have a fraction. The denominator we learned yesterday, which is the bottom of your fraction, is how many pieces you've split the whole into. How many pieces did we split the whole into? 5. How many pieces does the kitten get? 1. 1 1/5. Now we're going to solve this a different way. Draw your 6 circles again. I'm not going to draw them again. This time, let's say that you probably wouldn't do this for a kitten, but let's say that it's special kitten flavored treat milk. So like some of it tastes like chicken and some, or maybe instead of milk this time it's canned cat food. Okay? So you have like 6 different flavors and you want to make sure the kitties get all to try all of them. So this time we have to split every single one into, go ahead and split each one into fifths. Okay, very good. Just do what I'm asking.
Mr. Ross, or you can draw an X and put a poke in the middle. Yeah.
That could work too. If you have a different way than mine, remember I said if you have a different way, you can try it. I'm just telling you what I know has worked in the past. Okay.
Wait.
Yeah. So now once you do that, then you can just, kind of like we did with this one, every single one, give each kitten part of Now again, when we're finding our denominator for this, we just look at one of the circles, yes? So when we look at just one circle, the denominator tells us how many pieces we took one of those cans and split it into. How many pieces did we split each one into? 5. There are 5 pieces in one whole. Now you count and see, when you do this next one, we're sharing it equally. So we do know that each cat gets the same amount. But you just pick one of the numbers. Like I usually pick 1, but you could do it for number 4. You just count how many 4s there are. Does that make sense? But when you do the numerator, you're not just looking at one of the holes, you're looking at all of them. 1, 2, 3,
4, 5, 6.
6. Each kitten gets 6 fifths of a cup. Well, how can it be 1 1/5 and 6 fifths? How can that possibly be? Chat with a partner. Elizabeth throws a monkey wrench into you. Okay, I don't know what Falcon, how can it be? She gone. How can it be 1 1/5 and 6 fifths? One more fifth and make 6 fifths. Yeah, very good. Very good. Okay. Explain this black magic to me. I don't understand how this can possibly be. Delia,
They're the same.
how are they the same? Can you explain?
6 fifths is equal to 1/5.
Is equal to 1/5. Okay. Maybe go a little bit more in depth with it. Ava.
We basically said what Delia said.
Okay. Here's what it comes down to. Real quick, guys, so we can move on. 6/5 is the same as 5/5 plus 1/5. Well, 5/5 is the same as 1. 1 and 1/5. You guys see how we're getting that? Okay, so now we're on page 69. So I hope this gets me to page 69. Yay! Okay. It says, a group of 4 soccer players brought 6 gallons of water to the tournament on Saturday. If the players want to share the water equally, how many gallons of water did each player get? So, Braden, we're on page 69. We're going to represent the gallons by drawing circles. How many circles do we need to draw?
6.
Okay? There are my 6 circles. I'm going to show you how to make 6. Or excuse me, we don't have to make 6. How many people are sharing them?
4.
Okay, you're on your own. See if you can solve this. We'll come back together, and if you're stuck, try and think about what you should do next.
Someone's here.
Miss M. Eyes.
Maybe Mackenzie's, maybe?
No, it's not Mackenzie's.
No, it's not. Mackenzie's. Mackenzie was right when you were
Either ours or Langbeans. Check with Langbeans if it isn't theirs, and it's probably ours. Okay, how we doing? We need more time?
Yeah.
Let's keep going. I see people still working. Okay, Braden, what do we got to do here? Okay, can you show me?
Yeah, I found it.
Maybe we should actually split those in half. Huh? There you go. Okay, very good. If you can solve it one way, see if you can solve it a second way.
This will be one.
Autumn, tell me what I should do.
I split them all into fourths.
Okay, so you split every circle into fourths. Nothing wrong with that. That's a good start. That one kind of looks like a kitty, maybe, with its ears. See?
Oh, yeah.
Okay, Autumn split them all into fourths. Then what did you do, Autumn?
I numbered them 1, 2, 3, 4.
1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Got them. Now what, Autumn?
Then since there's 4 in each circle, that would be my 10.
Yes! I love the way you said that. There's 4 in each circle. So that's my denominator. Your denominator is going to be fourths. Okay, how many fourths does each person get, Adam?
6.
6. Because person 1 gets 1, 2, 3, 4, 5, 6. Do you guys get that I don't have to count them for every person though?
Yeah.
Yeah, it's the same amount. So 6/4 is Autumn's answer. Did somebody do it differently? Gavin or Porter? Gavin, did you do it differently?
I did.
You did, okay. Let me draw my circles again, Gavin, and then you tell me what to do, okay?
Oh, it's killer.
Oh, Porter did? Okay, Porter, let me draw my circles and then you're going to tell me what to do. Okay, tell me what to do, Porter.
So each player should have each player should have one gallon of water first.
Okay, so what you're telling me is person 1's going to get this one, person 2, person 3, and person 4, like that.
And then I switched the other two into half so it would be equal.
Okay, then you realize, because there's 2 circles left, he could just split them in.
Wow.
And if he splits them in half, person 1 gets this, person 2 gets this, person 3 gets this, and person 4 gets that. So, Porter, how much water did each person get?
The same amount.
Well, yeah, but what is that amount in your answer?
1/4.
They get 1 1/4?
I mean, one second.
Okay. Porter, what would your fraction be for this?
Each 6/4.
Okay, but that's not what you have. Look, person 1 gets 1 gallon. Then they get this much of a second gallon. What's the fraction? How many pieces are in the whole, Porter?
1 and 1/4.
No, Porter. How much are in one circle? That's your denominator. How many pieces? Hey, okay, 2. I need you to answer the questions that I'm asking though. Because we're building. You're trying to jump to the answer. I need you to answer the questions that I asked. So how many pieces are in a whole, Porter?
3/4.
Porter! Look at this circle right here. How many pieces did we split that into, Porter?
2.
2. Thank you. That's what I've been asking. How many pieces does each person get?
What?
How many pieces does each person get?
1.
There you go. So they get 1 and 1. Thank you. Thank you. Okay, anybody do it a different way? Elizabeth.
I did, so, oh wait. So I had the 6 circles,
Okay.
and I gave them each 1.
Okay, you gave each of them 1. Person 1, person 2, person 3, person 4. Then what?
And I split the other ones into 4ths.
Okay, that's probably the other way that people could have done it.
And then I gave them each 1 of each.
So in your answer,
1 and 2/4.
each person would get 1 and 2.
Ooh, that's the bad part.
Yep. Each person is getting 1 and 2/4. Okay, so let's take a look at this because that's probably the answer. Is your answer different than what they have up there?
Yep.
Okay, how did you split it then?
I split all the circles into halves and gave them. Oh, that's what I did.
Okay,
I did it.
that's a good, that is another way. All right, I'll take a look at that. So, what Hadley said that she did, I want to go quick with this, so excuse my erasing. She split them all into halves. Person 1, person 2, person 3, person 4. 1, 2, 3, 4. 1, 2, 3, halves. Now, what I want to look at, we have 4 different answers here. We have 3 halves, 1 2/4, 6/4, and 1 1/2. How can it be all of these? How can they all equal each other? Well, let's take a look at this. If I have 3 halves, that's 1/2, 2 halves. I chose to overlook it earlier, but I don't think we're doing our best learning. I need you guys to do better. 1/2 and 2/2 make a whole plus another half, right? So that's this one. Okay? 1, that's a circle. See, they're the same?
Yeah.
And 2/4
That's the same.
is the same as
A half.
a half. It would just be like taking this guy and doing that, yes? 6/4. 1, 2, 3, 4. That's the same as 1 whole. And then on this next one, 1, 2, 3, 4, 5,
6.
this one, 1 and a
2.
half. You guys see how they're all the same? It's just, all you're doing, the only difference between these is that you're splitting the denominators or making the pieces smaller or changing the pieces. It's still the same amount. So it's kind of like if you had a cake, you could have 4 pieces. You know, you could cut the cake into 4 pieces, right? And you could have a 4. Or I could cut it into 8ths, but if I cut it into 8ths, and I'm sharing with 4 people, everybody would get 2 8ths. Or I could cut it into 16ths, but if I'm sharing with 4 people, then everybody would get 4. So when you change the pieces, you're going to get different numerators. Elizabeth, is that your best learning?
Yep.
Do better. You guys, come on. All right. I think you guys are doing pretty good on fractions. Let's take a look at math boxes for today. This is page 70.
Wait, can you try this?
If you want to, you have time. Okay, on this one, it's exactly what you were doing during our mental math. 3006. You're just writing that number. What would 3006 look like? So for example, I'll help you with this one. 3,000, no hundreds, no tens, 6. You guys understand? Okay, this one. You're rounding to the nearest 1,000. This one might seem a little tricky. We're going to do A, C, and E. You're only doing 3. So A, C, and E. Now A might be a little tricky because it's 825. You have 0 thousands. So that means it can either be a 0 or it can be a 1 in your thousands place, right? Okay. Remember, 0 to 4 you round down. 5 to 9 it goes up. Okay, which 2 statements represent the equation 16 times 2 equals 32? So 2 of those 4 should be filled in. on this one. D, D, and F. Now the tricky one, no. Yeah, then you miss out on all the fun though. Here's what we're going to do. Change that, scratch that.
Why don't you?
We'll just do the first four. Here's the tricky one right here. 3 feet, 3 inches. You need to change the 3 feet to inches, and then you need to add the 3 extra inches. How do you change feet to inches? Times 12. Do 5 times 10, do 5 times 2, add them together. Yards. How do you change yards to feet? How many feet in a yard? 3. Very good. Do both of them. A prime number. A prime number has only one factor pair. That means how many total factors? 2. 1 and the number. So here's an example of a prime number. An example of a prime number is 3. The only multiplication fact that you can do with whole numbers that equals 3 is 1 times 3. Another one would be 5. Another one would be 7. Is 9 prime?
No.
No. 9, even though it's odd, is not prime because for 9 you can go 1 times 9 and
3 times 3.
1, 3, and 9. How many factors?
3.
Not a prime number. So you're looking for, there's 2 of them, because usually when it says all that apply, there's 2. 2 of these 4 have only prime numbers in it. Yeah?
With the blanks in the middle of the numbers, does those mean zeros?
For this one?
No. In 6, there's like blank spots.
No. It's 2 different numbers. 4 and 56. Are both of those prime, or they both have to be prime?
Okay, I thought they were...
13 and 89, they're 2 different numbers. 37 and 53, 42 and 61. Make sense? Okay. People on the Zoom, any questions?